Okay, space farming with AstroSeed. We're going to learn a little bit about AstroSeed because I've done some reading on AstroSeed, but I'd love to hear from you specifically. So our agenda today, we're going to do sign-in and announcements, attendance for WP Carey's BSc, Business Student Council. Since we're part of WP Carey now, we have to take attendance for every meeting, and that's just keep track of how many people are coming to the meeting in general. And we're going to go on to some background information on the topics. And then we're going to have the Q&A section, which should be throughout the entire seminar. So feel free to ask questions, e-board and other members about anything we're talking about. And we're going to have a what's next portion where it's this news you need to know for upcoming events. So everyone scan this right now to sign in. You should have used clips from The Martian for your terraforming Mars. What?
It's a good movie.
It's a great movie.
I like to look more. It's better. You like to read? Yeah.
Okay, everyone got it? See? Still in Mexico mode. Okay, so most of you guys already follow the Instagram, but if you don't, follow the Instagram at Space Business at ASU. Give you a second to pull that up. All of our stuff is Space Business or Space Business Association at ASU. Thank you for that. I'm going to put that slide in. For our YouTube, this seminar is going to be on YouTube. We also have our previous talks on YouTube, such as Jim Kentrell's talk, co-founder of SpaceX. Super interesting talk. He does want to come in again this semester, so I'm going to reach out to him and see when he's available, and hopefully in person. That would be super cool. So I'm going to start out with the farming on the moon portion of our seminar. So recent analysis has found that lunar samples returned to Earth in the past has shown sufficient essential materials available for plant growth, apart from nitrogen compounds. The bad news is lunar soil compacts together in the presence of water. This causes problems with plant germination and root growth. So who can answer? How can we remedy this issue? Just spitball answers. Think about growing plants.
We need a different type of soil. The soil isn't work, or to modify the soil.
True.
Bring Earth to moon. Yeah.
There's a specific type of farming I'm trying to get out of y'all. Good answer.
It's not very specific.
Come on, Vishnu. You might know the answer to this one.
Hydroponics, aeroponics.
Yes. Yes, there it is.
Ding, ding, ding.
Hydroponic farming therefore offers practical alternatives to this type of agriculture, involving feeding plant roots directly with nutrient-rich water without the need of soil. So the moon already has these nutrients on it, but you can't create soil from lunar soil, like plant-growing soil from lunar soil, because when you mix that soil with water, it compacts together way too much where the roots can't penetrate the soil. So you extract the nutrients from the lunar soil and you farm without soil. So achieving a sustainable presence on the moon will involve using local resources to gain access to nutrients present in lunar soil with the potential to help cultivate plants. Current studies show from Solsys, I don't know how to pronounce their name, Solsys Mining represents proof of this principle, where they have been able to grow plants using lunar soil as stimulants. So this mining company is optimistic because they had already cultivated blank using stimulated lunar soil. Now, can anyone guess what plant they've already cultivated using this method?
Arugula,
What is that?
like lettuce,
Lettuce? That's a
Yeah.
good guess, but no.
basil.
Basil? That's also a good guess. No, that's a great guess, but no. Come on, guys, it's simple.
Yeah.
Trees?
Tree.
Potatoes? That's a really good guess. No.
Carrot.
Think simpler. Carrots is close.
Potatoes.
Close.
Radishes.
No.
Beets.
Very close.
Eggplant.
No. Any other guesses?
Beet.
Wait.
Yes. No. I was gonna give it away. No. Colder. Starts with a B. Banana? No. No.
Said that.
Basil? No.
Base.
Battlestar Galactica. Okay, you guys have used up all of your guesses.
I'm so curious.
It's beans. Beans are changing our lives. Okay. Cool beans. They've cultivated beans using nutrients from lunar soil. Very cool beans, and we'll be eating a bunch of beans. I don't know how going to the bathroom on the moon is going to work after all the beans consumed, but we'll have to figure that out later on. AstroSeed, take it away.
So as Josh explained, we are trying to feed, right? But unless until you're a rabbit, you can't live with just feeds, right? So before going to Mars and Moon, we'd have to start doing research on plants in space. Right now, only NASA is doing space research on plants in space right now, because partly only NASA has ISS. And so if you don't know, NASA is deorbiting the ISS, and by the end of 2030, there will be more than 2 or 3 private space stations out there as their own companies. So they are looking for solutions that provide infrastructure to grow plants in space, and they are looking for infrastructure that can take the research on plants in space as well. What we do is that we're providing that infrastructure that that is lacking in space right now. Right now, if you go and see what's happening in space in ISS, they have a small hydroponic station wherein they're growing lettuce. That's it. And they've grown some basic vegetables like bok choy and some random stuff. I forgot exactly what they're growing, but they're growing some stuff which is not enough for us for our survival. If they're planning to go to moon or something like that, they have to have like a complete nutrition plan so that astronauts are nutritious and also can live. So yeah, why we're doing this? Why building our plant modules? One is, as I said, the research on plants is very limited, and along with that, if you go and see what astronauts are eating right now, it's just dry food, right? Even cats don't eat dry food, so there's no way we're eating dry food. And we want to venture into deep space. We want to have fresh food, and we want to have that deep connection towards nature that makes us human, right? That's what has been missing in the ISS right now. If you're an astronaut and you work with metals for like 10 hours a day, the last thing you want to go back to is metals to your sleeping quarters, right? You want to have something different. And what plants offer along with nutrition is that connection towards nature that makes us human. And it's a very vital part of what makes us human. If anyone has trekked to like the top of mountain, you feel something different, right? The feeling that you don't feel it in the nature. That's what our modules provide. As I said, so say you work like 10 hours with metals, you can come to a module, just chill out with your friends, hang out, play cards. Apparently, you can beam Netflix shows into ISS. So, you can have movie nights in there if you want to, or have space beer if you want to with your friends. And probably the most important reason I would say is plants are cool, and we need plants.
How are you gonna pitch this like to businesses saying like oh, we need this like mental health space for our employees who are in space. Because these pods cost money. So how are you gonna pitch it to businesses? Other than like, because these pods are not just for growing food, other than using like all the space to grow food, how are you gonna pitch that we need an area where humans can experience nature?
That's a great question because if you see what NASA is doing right now, they are also doing some experiments called wedge experiments, wherein they're understanding how plants affect humans. So, I mean, along with, as I said, along with nutrition, it kind of gives their connection towards nature, and it helps them in productivity. It increases humans' productivity by as much as 30%, according to the researchers
Really?
on Earth. 30%. So if it's increasing by 30%, it's worth doing it. And
Have
it's-
you read the study that hospitals that have a window that use nature, patients actually heal significantly faster than hospitals without a view of nature. Even an image of a tree in a hospital room helps those people heal faster. So if it's proven statistically to help people heal faster, what else could it do? You know, for mental health,
Exactly.
all that. Yeah.
I mean, along with mental health, forget about mental health. Even if you're living in space for more than 6 months, you want something different, right? If it's just metal of the metal of the
Yes.
metal, it's like, yeah. And if you're going more than 6 months, if you're
Seeds
spending
are
like
also
what?
lightweight. So
Sorry?
you can bring plenty of seeds and have you know a whole farm in a bag basically.
Exactly. I mean, these modules are very big. So think of it like big, as big as
Like a
ISIS
shipping
shipping
container
modules.
size?
Yeah, shipping container, 40
Wow.
feet shipping containers. Yeah. And so, yeah, these are cosmic pod. Imagine a pod like this, wherein there are plants growing, and then you can float around, and they have like a hangout space at the end of the module, when you can see like the digital cosmos on the left, or on the see in the middle, you can hang out. You have
I
the
can't believe that one day people are actually floating around there. You know,
we want to make it happen.
it's cool.
Let's
It's
make
cool
it
to put
happen.
yourself.
I mean, as I said, you want something different, right? And plants provide that difference along with this nutrition.
This is kind of off topic. Do you think that we would ever farm animals in space?
How
Would that even work in zero gravity?
I mean, I don't know about reproduction, but
Yeah.
we can
That's what I'm
take those.
thinking.
We can take animals from here to there, and probably. I mean, the first animal that's been sent to space was a dog, right?
Yeah.
So if it can live, probably we can.
Is that your art?
Not art, but like AI art.
Oh,
Put it in AI and then output
it.
stuff out of it.
What other, you said that a lot of people are working towards this like problem. What are other solutions?
So there's only one company, as far as I know, that's working on building plant modules for space, and it's called Interstellar Lab. And if you see their design, they suck. They're for only plants. They think of their modules as a research laboratory for plants. What we are offering is that it's along with our module acting as a research laboratory, we are also offering these hangout places, and it's a module where you can do research along with and act as a hanging out spaces for astronauts to do it. That's what we offer.
You could potentially like make modules to add like basically like pots, you know, in different modules as well, right?
Yeah, that will be doing that too,
Oh,
because that will be our first step, because if I go and ask you $100 million, you'll say get out of here, right? So that will be our first steps,
One thing
doing
at a time.
doing
Yeah.
small modules, and then building a big module. Yeah.
Gotcha.
But again, we are at the end of the day students, right? We have done nothing. If I say you're an investor, and if I ask you $100 million, I've crunched on the numbers to build a big module like this, it comes to be like $200 million. So if I ask you $200 million, you'll say, get that out. So to do that, we are starting off building plant modules on Earth, and then going to space after that. So when I say plant modules on Earth, think of these plant modules as this big shipping container modules, wherein you can grow plants. And I mean, the reason why we're even building plant modules like this vertical farming is because if you see traditional agriculture, it's very resource heavy, right? You need a lot of resources. Like if you want to grow corn, for example, in ASU, imagine growing corn in Arizona. It's not native, and at the same time, even if you want to grow, you have to get materials, you have to get all the stuff that's required for plants, and then like, if you have like a module like this, you can grow whatever plants you want in that space. Environment in that module is completely controlled, and you can grow plants in the cities itself, right? So you're cutting down the food waste. That's usually because most of the food that you get in your Walmart or Target is usually shipped down from like Idaho or something, because you can't grow stuff in Arizona, right? And say you're in New York, for example, which also has very harsh weather. So you can't grow plants in environment like this. So you grow plants, usually plants are grown across the country and then shipped down to cities, which obviously increases the carbon footprint and also increases the uh, journey of traveling of food from one place to another place. You have a module like this, which kind of replaces like 3 acres of traditional agricultural land. If you use a big 40 shipping container, you're essentially cutting down the carbon footprint. You're uh, decreasing the food miles from like 1,500 miles, that's the USA general miles, to less than 100 miles. And it also, as I said, provides that connection towards nature. If you go to a place like New York, for example, say it's minus 20 degrees and it's completely icy in your backyard, it's the same situation as an astronaut, right? For an astronaut, it's black and space. For these people, it's completely white and stone. But the problem still remains the same, is that they're missing the connection towards nature.
How
Yeah.
long would it take to make these plants?
It depends on the plans. Our models are completely automated, so you don't have to do anything. You just press your button in and then let them go, right? You say you're planting lettuce, for example, it takes 15 to 20 days to grow. And our USP of our module is that you can grow whatever types of plants in that space. Usually in container form, they divide different types of plants, like all plants, to different types of plants, like leafy greens, microgreens, and they dedicate one container form to each and every type of plants. And if say you have a container form for microgreens, you can't grow leafy greens in that. What our USP is that you can grow whatever types of plants in that, which kind of negates which can differentiate us from the competition out there. Yeah, a module like this can act as a big automated luxurious garden, wherein you can put it in your backyard, enjoy with your friends. As I said, have a like earth beer if you want to, not a space beer, and then or you can also use it as a container form to grow food, which can be used or which can be sold across in your local markets. This is our Discord group. If you want to join.
Except for this one.
Okay. I'm like barely gonna scratch the surface with this. This is something that you could talk about for hours probably. But if you don't know what terraforming is, it's just modifying a planet's atmosphere and its surface or its entire ecology to make it suitable for life, essentially making a planet similar to Earth. Why Mars? Mars is obviously the next step for humanity. It's what everyone's talking about all the time. Has an abundance of raw materials, especially in comparison to the moon. And there is water in the form of permafrost under the surface, as well as at the polar caps. Okay. So when you're terraforming, there's 3 things that you have to look at, especially for Mars. It's the magnetic field, the atmosphere, and the temperature. So the first thing is the Martian atmosphere. It's almost non-existent, but it still exists. Its volume is 1% that of Earth's atmospheric volume. It's largely carbon dioxide, but plants turn carbon dioxide into oxygen. So why can't we? Moxie is this little guy on the Perseverance rover that is currently experimenting by converting the Martian carbon dioxide into oxygen. In an hour, it can make as much oxygen as a modest-sized tree. But the only problem with that is, why is the Martian atmosphere so thin? Where's the oxygen going to go? Is it just going to escape? Well, Mars doesn't really have much of a magnetic field left. So the solar wind ends up stripping the atmosphere away. Jim Green is, I think he's retired now, but he was one of NASA's top planetary scientists. He has suggested the use of a giant magnetic shield that could be placed in between the sun and the red planet. And this would help increase the atmosphere's pressure and thus the temperature, because Mars is very, very cold. I don't really understand. I was trying to read his article about this giant magnetic shield. I'm sure it's a great idea. His paper, I wasn't really, maybe I'm just not advanced enough to understand. But he's also mentioned that a lot of other scientists are not in favor of terraforming at all, but he's kind of ride or die for this terraforming thing. So I'm gonna trust him. So once they develop this magnetic shield, this would also allow the manufactured oxygen that we're creating, yes, to remain in the atmosphere.
What about using nukes to terraform Mars?
Nukes?
Yes.
I've
We
never,
talked about it in my space entrepreneurship class.
tell me about
Isn't
it.
the idea behind it to nuke the poles?
Yeah, you nuke the pole.
Oh, to release the water?
No, to warm that atmosphere.
Oh,
It creates an atmosphere because of the.
No, it just warms the planet and
Yeah.
it turns.
but wouldn't everything
It
escape?
doesn't cause like a reaction where oxygen or gas is released. Nothing.
That's so interesting.
It traps all the gas. It traps
That
all
would
the
be good. Why would it be good?
Wouldn't it turn it into like a Venus, which is not what we want?
Isn't Mars's
It's
atmosphere
too
and
far.
poles or
It's too far.
magnetic field are so weak that I've heard that one of the biggest issues with living on Mars and terraforming Mars is radiation, right?
Mhm.
It's the fact that there's not the protection that we have on Earth. People
Yeah.
already get skin cancer from the sun, and so then these conditions are much harsher.
Mhm.
It wouldn't even be direct sunlight; it would be harmful. It would be like what is it, infrared radiation or something. I don't know the specifics, but
So true, bestie. Yeah.
Because the atmosphere is.
Martian soil. So in some areas of Mars, the soil we think is already conducive to plant life. In some areas, there might be fertilizers that we'd need to use. Vishnu talked about this a little bit. The veggie plant growth system that they're testing on the ISS right now, which would serve as a sustainable food supplement for astronauts on long flights and on planets. And this is, I don't think this is like, or maybe in Israel, it kind of looks fake. It's fake. Oh, yeah, it's just like an artist rendering, I guess, of what a pod, like a little veggie pod would look like on Mars. It would also serve to benefit on long space flights as well. NASA's also working on creating simulating a Martian soil and trying to grow plants in it, and just seeing what types of fertilizers we need to use, how we would keep the plants growing after extended periods of time. And I think that's all I have, to be honest. Yeah. Ooh.
all right. So I'll be presenting on an issue that's sort of in the background with space travel. So just like building up societies, since the industrial revolution, the amount of carbon that we've emitted as a species, burning fossil fuels primarily, has led sort of by accident to changing the entire condition of the atmosphere. The very chemistry of the atmosphere on this big blue planet has been shifted on accident by humans. That just goes to show our general capability, and our capability. The pinnacle of it, arguably, is space. And just like all of our endeavors, there's pollution, there's waste that's associated with them. So I want to address this problem and then relate it back to some of the concepts, some of the environments and ideas that we've discussed already. All right, so first I'll just give a little background with some numbers. So NASA's tracking all the space debris possible, kind of monitoring for this problem, and then just to plan satellite launches. So there's 26, that got cut off. It's 26,000 defunct satellites, and up to 500,000 smaller objects, and then beyond that, there's 100 million they predict untrackable objects. So that'll be like little flecks, things even down to the size of a grain of sand or smaller. And all these objects come from the destruction or the existing collisions of satellites. So we shoot up or not only satellites, but general rocket components. So there's stages, and these stages get left behind, and then and usually they float around. Sometimes they're able to return to Earth, but they're primarily in low Earth orbit, obviously in large numbers. They travel at speeds of 18,000 plus miles per hour, and that's fast enough for even one of these smallest objects, when it comes into contact with another object, to completely destroy that other object. So then that leads into this problem of a potential of a chain reaction. So every item that crashes into another item, both the items break, whether they're small or large, causing more debris, and potentially that could lead to an exponential increase of pretty much creating a virtual or a real but invisible space prison, or prison around the Earth, where Earth would be inescapable by rockets, taking decades to centuries to alleviate itself naturally.
So
Currently,
would it be, like, completely around it in the globe, or
it would since the Earth is a sphere, it would proliferate to completely cover it. So it wouldn't be patches. It would be patches. It would be spotty, but it would just scatter in every direction, yet be held by gravity. So it would cover up the whole globe potentially. Scientists project this could happen within 10 years. Hopefully this doesn't happen, and hopefully people like us and people in the SBA will address these issues and incorporate them into their work. And so yeah, like I said, currently satellite loss only 3 to 4 a year. It's increased slightly in the last 50 years. All right, so different solutions. This is just some stuff that I researched. Less wasteful rocket technology. So SpaceX is a big innovator with rockets that are able to land, the primary stage of them back to Earth and be reused. Forms of transportation. A new form of transportation is another one. So there's a couple companies that are working on developing, planes that travel at high speeds, at about as high up in the atmosphere as they can, and then they release a rocket. They're holding a rocket on them, and then that rocket goes into orbit from there. Space elevators. This is an idea that Japan kind of originally tackled and said that they would bring on, but they haven't done any work with, and it's a little tough with the materials that we have right now to create one. But there's more than one way to get to space than a rocket in theory. And then orbital acceleration. There's also ideas like slingshots. So having taking less fuel with less stages up to the orbit, to have sort of like orbiting launch pads to go to Mars, to go to the moon.
I pitched a idea that I can show you guys later on.
Josh is the one that Josh gave me this idea, or he first told me about this idea. There's some research that's done on it, but he also came up with a further innovation.
Was Gateway.
like exactly that?
Probably, yeah, it's probably that then. All right, and then larger payloads. So obviously, just like anything in physics, when you have a bigger container, the ratios of the surface area of the container and the volume is inverted. So you can store more, you know, if we develop larger rockets with creating less waste for fuel primarily. So, and then things that we can do to take care of the debris that we will have in the future and that we have right now. There's space nets. So that's pretty self-explanatory. I think that's insane that we could potentially capture this debris going so fast, but people are working on it. Space lasers. This is a really important one. The small pieces can be vaporized, and the larger pieces, one side of them can be heated up, and that actually causes a reaction, which causes the satellite to move. So it gains momentum from there, and we can push satellites or large space objects out of orbit, potentially back into orbit for them to burn up. And then space magnets. So having magnets that actually attract debris and then shoot them away from orbit or back into orbit. So I don't know, cool stuff.
UK government, I think, is last year
Ah.
announced $2 billion.
We need as much money as we can get, as many people work on this as we can get, it seems. This is just some I'm not even sure. It was on NASA. I'm not sure if this is just, I think it's just an artist rendering of what this sort of thing could look like. So it's straight out of Star Wars or something. And then I just have some discussion questions. There's some stuff to I don't know. A lot of this stuff, it's pretty theoretical right now. We haven't ran into these problems on a large scale, so we haven't had to deal with them. But all right, is space farming worth the pollution associated with launching rockets? So what do you guys think so far? Space farming. Do we like it? Do we hate it? You know, do we want more of it? We know your take. You know, this is your thing. So you are very pro space farming.
I mean, it's needed to become sustainable in space.
So it seems like we probably can't go to the moon, go to Mars, and we can't like live there or spend much time in space without space farming. Potentially that will be a necessity. You know, pretty much. And in the event of Earth, something going wrong, you know, that's another reason why if we want to set up, you know, a home on Mars, we gotta make our own food.
Unless we become like a robot.
Unless our stomachs become USB ports, yeah.
Space farming is be necessary to the degree of like producing so much food. Because I don't think if we are going to the moon or to Mars, I don't like.
It's not nutritionally dense as well.
Yeah. I mean, especially if you're like looking back in history, like you know where like far past where there were only just farms and where you couldn't hunt and farming was like really like a big thing. The nutrition value of humans, like when they would research them, they did not have a long lifespan because they only ate the exact same things all the time. I only know this because I class on it, but it was very bad for them to only sustain on farming. So.
That's just another layer of why space travel is difficult.
Yeah.
So space farming, it seems like it's going to be a necessity. It's a great thing, but we need more than that. We need to figure out, you know, further solutions. And
it feels like a non-vegan talk, to be honest. All if you go speak to a vegan, they're like, no, you can get what nutrition
Yes.
you get from the plants itself. You don't need meat.
Do you have any stats on how much square footage it takes to feed a human on like a weekly basis or something like that? I don't know. I would be curious. You know.
One that I know is that like a big shipping container, like a
Yeah.
big shipping container can replace like a 3-acre traditional farm,
Okay.
traditional land.
And it's nice because you can go 360, right? You can use every surface if you'd like. All right. What do you guys think about terraforming Mars? Do you guys have any opinions on it? You gave a great presentation. Definitely learned some stuff.
I don't think it's viable. It's gonna take, if we nuke the poles, it would take so like long for it to actually take effect.
And then you got to figure out how to get nukes to space, which I think is a no-no.
True.
Yeah, nuking is not a solution.
I've heard using lasers. I don't know. I like lasers.
I don't know. I like the giant magnetic shield. I think that's fun. I think if that guy can figure it out, I like it. I don't know what it entails, but he's really passionate about the magnetic shield, so.
All right, so you're down to terraform as long as we have a magnetic shield.
What
Yeah.
else are we gonna do?
What if we can make it?
Like, what about society? Like, how do we, if we're terraforming Mars and start living there, what is gonna bring the brink of moving people to Mars? Like, everyone else stays on Earth, like interstellar.
I think we got to figure it out. I think we should just get there and start getting good at it, and then see if we can fix, other problems, and then move over. Because then it's also not going to be desirable to live on Mars unless you're kind of insane and really, really like space. To want to get launched in a rocket. And go through all that.
Why are you based on profession? Like scientists first, they'll
Yeah.
be a doctor.
Just like
builders.
yes, yeah.
So it'll probably.
It's a new frontier.
If you don't want to terraform, one solution that remember the Jimmy Franklin talk?
Yeah.
He spoke about living underground in Mars. So that's one way to circumvent terraform. If you don't want to terraform and it is too right, and the big holes in it.
Yeah,
I don't know how I would.
potentially. I mean, if you have big enough drills, you can find caves and make it happen.
It's also easier.
And you get
to
protected.
drill on Mars because the
Ah.
gravitational
Well, that's right.
force of it is less, or like less resistance.
So the rock
to
isn't as
drilling.
dense.
Well, Mars is just like smaller.
Yeah.
I don't know.
So does that lead probably then because there's less gravity to smush everything, right? Let's see. And then I kind of already mentioned this. There's you can make a pretty good argument, using tenets of sustainability. Sustainability likes to acknowledge the trade-offs between the economy, between people, so equity, and between the environment. Sustainability isn't simply fighting for the environment. This is what I'm a business sustainability major, taking a couple classes directly addressing this, and I feel like mapping it over space travel, mapping these theories that we've already proven, these feedback loops that we've already acknowledged, is something that should be genuinely incorporated. So that, for example, with this pollution of low Earth orbit, so that problem doesn't bite us in the butt in the future. So acknowledging those different factors of making space comfortable, like we said, of making it economical, and then of making sure that we set ourselves up long term. All right. And all right, that's that for me. Hand it off, JWST.
Okay, this whole concept is has nothing to do with this. This is just new space news that I want to talk about because space news is cool. So if you guys don't already know, this is the James Webb Space Telescope up there. Yeah, it's super duper cute. It made all these beautiful images.
That one in the corner is really famous, right?
Yeah.
Actually, all of them are.
Yeah, this one got a lot more famous recently because of the James Webb Space Telescope. This is a 3 pillars of creation, and this is in visible spectrum. And then this is in infrared, and you can really see the backed-width wavelengths. Like the longer it is, the more you can see through. So like this is just space dust, and you can see through all that through all the stars. This isn't James Webb though. This is Hubble. I just wanted to show you the difference between the different wavelengths. If you're ever looking at a picture of space and you want to know if it's Hubble or James Webb, you just look at how many spikes there are in the stars. If it is 6, then it's James Webb. If it's 4, it's Hubble. Like you can see 4 here. And that's just because the James Webb Space Telescope has 18 hexagonal mirror segments of gold plated. And so it creates that type of plating. So this is okay. So the James Webb Space Telescope actually looked at one of these stars. This is none of the images. It's called the Wolf-Rayet star. It is incredibly hot. So over here is the HR diagram. This is how astronomers rank stars. And this is our sun right here, and this is surface temperature. So you can see that the sun is around 6,000 degrees. And these Wolf-Rayet stars can be 20,000 to 201,000 degrees. So that's like way up there. And this is a main sequence where the majority of the stars that we can observe play. And then these are O-class stars. The Wolf-Rayet stars are W-class stars, which means that they're super duper hot and high luminosity. So this is a Wolf-Rayet star compared to our sun in size, they're really big and they're really blue because the more bluer an object is, the more hotter it is. The same thing as when you look in a flame, the inside is blue, outside are reddish.
The red dot is sun?
Huh?
The red dot is our sun?
Yes, this is our sun. And yeah, it's really, really big. So I'm going to show you this video. So this is what the James Webb went and looked at. So they went and looked at a Wolf-Rayet star. Since they are so hot, they burn up very, very fast. So they're very hard to spot and to take a picture of it. So the fact that the James Webb Telescope was able to take a picture of this is astonishing. Our astronomers estimate that there's only about 1,000 Wolf-Rayet stars in our local cluster that we can see. So being able to capture this is absolutely insane. It's 15,000 light years away, super bright, and these stars blast out their outer shell, which is called a nebula plume, and it causes these winds, which are about 10 million kilometers per hour, which they'll move. It is absolutely insane. So this is, okay, so this is the picture that it was taken. You guys will probably see it on the APOD coming up. You guys should all download the APOD. It's an astronomy picture of your day. But it's a very, very cool thing. And so you can see here, this is all the dust, and you can see the 6 little lines from the James Webb Space Telescope. And what you're seeing right now is that it is the gas of the nebula in near infrared, because it is so bright, it's able to reflect that. In fact, I don't know if you can see it because of the green thing. Can I move this? So right here is a nebula. And you're able to see it because of this bright star. Oh. But you guys could just see the mass of that. So all of this dust and purplish, you guys can't see with your normal eyes because it's in a different wavelength, so they just kind of photoshopped it to transfer it to visible so you're able to see it. This is super duper important because we kind of have a dust surplus right now, which means that our astronomers, there's more dust in our galaxy than there should be. And we have to understand why and where it is coming from. And so being able to observe this almost going to be supernova is incredibly important, because now we can understand what is behind it and where this dust is going and how is it being born and how it interacts with the stars. It's very cool.
Do you happen to know any of the implications of there being too much dust?
Like why there is?
Why, I guess, too, yeah.
Well, that's what they're trying to figure out. But it's called the dust budget, basically, if you want to look that up. Yeah, so Webb is a near infrared camera, and you guys can see all the gas that it's coming. It's super duper cool. And so when it goes further away, it cools down, and that's why that's like where the edge is.
It looks wispy.
Yeah. And then this is a star that's about to die. It's about to go supernova. And this dust right here is 30 times the materials that are in our sun. So if you take up all the materials that are in our sun, it's 30 times that. So far that is given off, which is absolutely insane. And I learned all about this today. I just found out today.
It's a good day.
It is an amazing day.
Amazing. I was so happy. Okay. And so if you guys want to learn more about this,
What's with the little light spikes now? So there's a 6 and there's 2 more.
what? Oh, these?
Yeah.
So if you look at never okay. Oh, okay. So if you look at the James Webb Space Telescope, you could see this.
That V-shaped thing?
Yeah. And that's just kind of like pointing out. And so you will get like a line going
Yeah.
through. You could see it on these images too. It's very small, but it's because of that. And it is. Yeah. It's very, oh my God, it's so cool. And if you guys watch the APOD, it's gonna be crazy. But what's gonna appear is these new galaxies. So there's a guy here named Roger Winhurst, and he works on the James Webb Space Telescope. He actually helped build it. Now he's doing a research group here. And he's been working with a ton of data. They actually produced one of this James Webb images, and it's in the Goldwater building. So you guys want to go check that out. But he's giving a talk tomorrow. He's my advisor. I work in his research group. Tomorrow at 6 p.m. in the Marston Theater. Slight plug, but if you guys want to learn more about it, it's super duper cool stuff. And he's an amazing guy, and he'll probably be talking about this. Okay, that's your
Nice.
space news for today.
Thank you, Em.
Space news.
All right. Good job, everyone. We're gonna stop sharing, stop recording.
It might be wallpaper. It's so good. It's so good.